Hi. All right. So Maddie has joined. She is going to be our community fellow supporting this session. Um, Steve, you're one of the two or three speakers. Is it
Correct?
two or three?
hmm I
Okay.
think it'll be two.
Great. Okay. Excellent. So, I mean, we've still got 15 minutes. Looks like everyone, the screen share is working great. So, yeah, we'll see, who else joins. The waiting room is active. It's already recording. So I'll give us like a 3-minute warning and I'll keep an eye out for Ben.
Okay.
Sounds good. And Zoe, is there anything specific that you want me to do other than just like be on standby in case people have questions or anything?
Yeah, so uh it hasn't happened in a bit, but sometimes the
Yep.
internet goes out at my house. So
Okay.
just if I do get booted off, hopefully it would make one of the co-hosts host.
Okay.
And Steve, if it bumps it to you, just bump it to Maddie. Really, all we're doing is monitoring the chat, making sure, like, um, you know, any questions get asked at the end. But
Yep.
really, this is up to Steve and Ben to run it how they want, unless there's something that you all want from us. Like, do you want us to, have people raise their hands? Do you want people to be able to? So, actually, that's a good point. Right now, people can unmute themselves and turn on their video. Are those settings that you want, or do you want that kind of shut off?
That's totally fine. You can leave it on.
Okay, so right now the chat is active. They can rename themselves, they can unmute themselves, and they can start video. I've turned off request for AI companion, record to computer, and some other requests of the host. But if at any point you think you want to mute the chat or anything like that, just let Maddie or I know. But yeah, we're just here to monitor really and make sure, nothing breaks, I guess.
Okay. Yeah. This is my
Yeah.
first time doing something like this, so it should be interesting.
Hey, you know what? Me too, because I started at ESIP in May.
Oh, nice.
So our other meeting is in person in July, and that's a very different experience. So
Mhm.
um, yeah, I've monitored Zoom before, but as far as a full virtual meeting, yeah, this is my first one too.
Yeah, same.
Yeah, I mean, I'm used to giving like a 12-minute talk at a meeting like AMS, but online. But yeah, doing a whole like yeah in front of people I don't know. Like I teach online too, but I know all
Yeah.
those people, so it'll be
Also,
interesting.
and
Oh, there's
actually Ben
Ben.
just arrived.
Yeah.
Yeah. Let's see. Make him co-host as well. All right. So now Ben can share screen as well. So, hi, Ben. I'm Zoe, and this is Maddie, our community fellow, who will also be supporting this meeting.
Thank you, Maddie.
Hello, hello.
Um, and I was just telling Steve, all of the participants will be able to unmute and show their cameras if at any point or whatever you want to turn that off. Maddie and I should be able to do that. If for some reason I lose internet, which has happened, but not in a while, just make Maddie the host, and she'll just make sure no one Zoom bombs it. But yeah, Maddie, if you have any questions for me, you can Slack me or anything like that.
Sounds
But
good.
yeah, we're just here to support you too. That said, I mean, I'm looking at the notes document, which is linked in the Kiko chat. I put my name down. If there's anything you want from us to kind of try to engage people, let us know. We can maybe put a prompt in the chat or in the notes document. We're not going to take notes. I think that's up to you two in that document or anyone else. I think anyone can write notes in there. But yeah, anything you need, let us know.
Okay, I think we're in good shape.
Okay. And I'll, give us a 3-minute warning. I'll turn the waiting room off maybe with a minute to go. But if you all want to do any screen sharing, Steve already was testing his, but anything you want to do before we let people in, go for it.
Yeah. Good enough.
Looks great.
Mm-hmm. Yeah, it's so interesting to really think about the in-person and the remote meetings. Like, definitely stuff comes up like, oh, this would be a great in-person meeting. Like, oh, no, this is, and this one is ideal for the winter meeting. So I'm really glad we have this pattern.
Okay.
And I'm so happy I got Steve to an ESIP meeting.
There's not too many faculty here, I noticed in the list of attendees.
Mm.
I guess, yeah.
Or maybe a couple.
Mm-hmm.
It is a school week, right? Like most schools are back in session.
We are, yes.
Yeah.
I've had to put bars over the door and everything else.
Yeah, I went to a weird school that our breaks were very, very different from most other schools. Like we never started our fall semester until after Labor Day.
Mm-hmm.
And I don't think we came back from winter break until after Martin Luther King Jr. Day. So we were always a little later than everyone else.
But you got great deals on vacations, travel.
Yes. Well, the entire reason we couldn't start until after Labor Day is it was in Rhode Island, and a lot of the students in the area were reliant upon those summer vacation homes being vacant. And so most of those summer rentals went through Labor Day. So the school knew our students are not even going to be living here until the tourists go home.
That's wild.
Wow.
Yeah.
It's not just like, oh, we're on the quarter system. It's actually a logistical reason. Yeah.
Yeah. It was really interesting. Yeah.
For us,
Which meant we got great deals on houses, but we had to get out of there by Memorial Day too.
Yes.
Good stuff. For us, the semester starts up after MLK Day, and I think that part of it is just like some folks just don't want to be in Ithaca in the winter, so they're like, nah.
Put it off as long as possible.
Stay away for a little bit longer, come back into January.
I wonder if that's the case, because yeah, I mean, New England school as well. That was maybe that's the case.
Yeah,
Stay away from the cold.
Yeah, the gray winter.
Yeah.
Yeah.
Yeah. My grandparents were in Cortland, which is right by Ithaca.
Yeah. Oh, amazing!
It's a land of land of
know.
stratocumulus clouds, if you know what I mean. Just
Truly, for like 6 months of the year.
yeah.
But a lot of fun atmospheric scientists here. So, yeah. So that's your specialty. You mentioned AMS.
Yeah, I'm a cloud physics precipitation person.
Awesome. Oh man.
So therefore, I mean, I'm from New York, but the snow drew me to Oswego rather than Ithaca.
I love Oswego.
Yeah.
Oh my gosh, fun. They Oswego's like right on
the lake. Yeah.
Yeah. I like, Rudy's Drive-In.
Oh yes. Oh, yeah.
The like beach right there has like some of my favorite rocks in this whole area. They're like perfectly round, and it's like it's an awesome spot. My background's in geology, but I've been now gravitating more towards like hydrology and atmospheric science, and Oswego has it all.
Yeah. It's a very interesting spot.
Yeah.
Best sunsets in the east, I think.
I believe it.
Mm.
I believe it.
What a journey from rocks to air, I guess.
Yeah.
I know. I've covered pretty much all the abiotic components of Earth.
Yeah.
Pretty great. Uh,
Yeah, my background was in geology as well, and then got my master's and pivoted to policy and communication. But I love a good rock. Love a good
Love a good rock.
basalt.
Yep. Love it.
Okay. 3-minute warning. I'll close the room. I'll close the waiting room at like 1 till. We've got, I think, how many? Excuse me.
So close the waiting room, meaning people come straight in? Like
Yes,
we're live?
yeah. So I'll click admit all, and then there won't be a waiting room. They'll be able to just join. So
stop being silly. Or start being silly.
Yeah.
Never. Yeah, wait, how do you turn off the waiting room, Zoe? I'm just curious because I don't actually know how one does it.
Do you see the shield at the bottom? It says host tools, or is that just for me as host?
Yeah, I can get to that. Yeah.
So there should be a slider that says enable waiting room, and you can slide it off. Yeah.
Amazing. Good to know.
Yeah.
Good to know. Cool.
Also, something to know, which don't click this, but if you go to, I think it's still under host tools.
Okay.
You click participants. There's a red line that says suspend participant activities. That shuts it down. That's like everyone is kicked out. That's if we're Zoom bombed, right? And there's something we don't want to see. It doesn't happen, really. It's happened like twice in the last 5 years, apparently, but that's where you go to do that. But then you'd need to completely restart the meeting and people would need to rejoin again. So
the big red
don't
button.
click it.
Good to
big
know.
red button.
Mm-hmm.
And also, as co-host, I think you can kick out individuals, but then they cannot rejoin. So also smaller red button only to be used in emergency.
And so
I don't think we're going to have that many people, so I'm not worried.
Yeah. And so you're going to officially kick it off? Like we'll sit here and you'll say, and now take it away, Ben.
Sure. Yeah, I'll go ahead and do that. And we're 1 minute and we've got a couple people in the waiting room. So I'm going to admit all. And, yeah, and then we'll whoever is speaking, I'll try to spotlight you. So, all right, here we go. Admit all. All right. Okay. Hello, everyone. Thanks for joining this breakout session. We are here at Teaching Machine Learning Techniques Using Agentic Coding. And we'll be here for the next 90 minutes with Ben and Steve as your main presenters. So I'm going to turn it over to who's presenting right now. Is it Steve? It's Ben. All right.
Yes.
Ben, I'm going to go ahead and spotlight you. So take it away.
Okay. In the spotlight. So welcome, everyone. This is really a very interesting topic that has been consuming a lot of my brain for the past year. And I was really happy to start talking to Steve about this. And we've brought in his grad student, Alfonso, and then a fellow eSIPper, Sandeep, who won't be able to join us today, but contributed quite a bit to the slides. So this is a group effort. And so we're going to start off just some level setting to make sure everyone knows what we mean when we jokingly say vibe coding. And, I know that it's causing quite a bit of anguish in the teaching community about like, what does this mean for the classroom? And so we'll talk a little bit about this and so exactly how we apply this. One thing is I love interruptions. Steve, I think you do too. So this is not a plenary, so feel free to interrupt as much as you want, or we'll have some pauses to try to make sure we have time for that. So, okay, so one of the big things that makes many people's heads explode is large language models, which is AI, and then machine learning, which we often call AI. And so we're trying to distinguish these. And so what we'll be talking about here is using large language models to write scripts that'll do like classic machine learning. And so we'll be talking a bit more about what we should be using large language models for and what we absolutely should not be using large language models for. And so that's one thing. So distinguishing between LLM and then like classic machine learning. Other thing is, we've all used ChatGPT or Claude or any of these other chat clients, and that's one way of using large language models. There's now these coding agents, which is a very different way of interacting with large language models. And so we'll talk a bit about what these two things are and how they differ. And then another concept that really fits into like the classroom especially is RAG, retrieval augmented generation. And so uploading a text space to a large language model to ground what it says, and that fits quite interestingly into classroom use and trying to reduce hallucinations. So, LLMs in science. So, LLMs, as it turns out, are really, really good at writing code. I've been writing code for a very long time, and we're now at the point that it's better. It's a lot better than I am. And so this is an interesting moment as a programmer. Like, what does this mean? So they're very good at that. And they're also surprisingly good at translating these scientific ideas into code. And then also, they have a lot more patience than I do for testing and debugging software. So they're really good at that. Our argument is they're not great at doing math. And so I have seen a lot of people who are trying to get LLMs to actually do the science, and I'm not sure. I'm happy to be shown that I'm wrong, but probably, they're language models, not math models, so maybe don't do like that. Don't abdicate all your human responsibilities and ask them to make the high-level architecture decisions. One of my colleagues today was saying, really, we're at a moment where we're transitioning from us being coders to all of us being high-level architects and being able to explain to the model what we want it to do. And so that's our human superpower, and so let's hold on to that. They're also not going to be great on deciding which data sets to use. And so that's something that you as an expert know these data sets so much better than the machine will. So that's one of the things you're going to hold on to. Definitely don't rely on them to decide, does this make scientific sense? I've made this breakthrough. No, that's another one of your things. And our colleague Sandeep, who works with the NSF, he put in with lots of exclamation points, please don't use LLMs to write proposals or review proposals and papers. They're great for helping you think through it, but come on. Okay. And so now, as promised, I wanted to talk about the different about chat versus these AI coding agents. So Claude Code, there's Codex, there's Quinn Code. There's a bunch of these things out there. And so they're pretty amazing. Right now, we're really into command line interfaces for them. Don't know how long this is going to last, but that's like, that is the trend. So there are these tools. They can, read through your entire code base and understand it. They can read the files, create files, edit them. And then what's amazing is they will run your code and look at the error messages and change the code to fix the errors. And so that's an amazing feature to have. And they can also do complex changes to your code that would really kind of make you sit there and think for half an hour of like, carefully going through it. And they'll just go through. And so it's a really great way to fearlessly refactor your code, doing things that you probably would be too lazy to do on your own. The chat clients, on the other hand, are really good for having just like open-ended discussions about architecture. And they're amazing because of all the things that they know, all the websites that they've read. I learned so much about Python packages that are popular, well-supported, that I've never heard of. And it'll say, here's a thing that may not even have routinely been used in our field that it'll suggest. It's also, they're great for just kind of thinking through and describing coding concepts or different architectural decisions. You can use them for writing like an individual function. Like, you sit there in the chat client, and I think Steve will show some great examples of what it's good for and where some of the limitations are. But you can interact about a particular function if you're really trying to figure something out. And we all, I think, have experienced how the chat clients have pretty much replaced Stack Overflow. They're pretty amazing at it. They get lost. It's fun when they just start churning through, like, try this, and then it comes back to like, oh, you should try this. The first thing it suggested, like, no, that didn't work the first time. It's not going to work this time. So occasionally the human does have to get in there. And so, so they're just really good in terms of just the interactive back and forth discussion. Okay, and then this is one that I was at a workshop in the summer when I started talking about this, and they just about voted me off the island when I brought this up. So the role of commercial technologies. And so I come from an industry consulting background, and so I'm naturally like, oh, yes, let's use commercial tools. And there are some great reasons that we should not be relying on commercial tools in research. My argument today is that this is all so new, so unexplored, and the commercial tools right now are the most advanced, have well-documented workflows. And so my approach for the rest of this talk is let's suspend judgment. Let's use the commercial tools. I have a $20 per month subscription to Anthropic. You can get pretty far with that. Let's figure all this out, and then once we get something that works for us, then see how we can migrate this to the open weight models and the open source tooling. So there are a lot of good reasons that we don't want to bring the commercial companies into the tent, but bear with me. Does anyone want to have other thoughts, rebut on this at the moment? Happy to take that. Otherwise, you're now all complicit in this, and we're going to start talking about some commercial tools for some of what we're doing. So, Claude Code, at the moment, from people I talk to, this one seems to be like the most popular and the most powerful agentic coding tool. And it's interesting that, yes, there's the models that sit behind it, but then there's a lot of stuff inside the agent that tells it how to interpret this, how to do debugging and all that. And so you can actually, there's sort of you can convince the Claude Code command line interface to use any LLM as the back end. There's a couple of tricks that you can, don't ask Anthropic to tell you how to do it, but there's a lot of some tricks that you can make it do that. And then people have seen that, sticking with Claude Code for doing the kind of the workflow, and then you can still use a cheaper model. So that could be a, neither half man, half goat type of approach to this. So this is what I've been using. Kate points out that Noah has enterprise license for Google Gemini. And I think there's like this whole thing of there's the model, there's the chat, and then there's the coding agent. And so I think Gemini, everyone says that they're the ones soon to be the ones to beat. So interesting to see where we go on there. So what I've done is I have a $20 per month subscription, and they say you can probably get 20 to 40 prompts per 5-hour window, and you can buy extra credits. And it is so much like drug dealers. Like, you're hacking. It's like, oh, you're out of credits. Would you like to give us your credit card and you can keep coding? Otherwise, you're stuck. So for $20 a month, I've been able to do some things like get my job done, and then I have bought a few extra credits, but Anyway, so this is what I think we'll be talking about, but other agents are available. So, as you know, the LLMs are trained on all of our stuff. That's what they did, is they took all of our, everything we've ever written and brought it all in. And so they know a lot. In some cases, they don't know some things. In some cases, they know too much. And so what we've seen is that if you just try to tell Claude Code without any other clues, go solve this scientific problem, sometimes it'll get it, and sometimes it'll just go off into directions that we don't want. And it'll also spin its wheels a lot, trying to debug stuff that we already know, or waste tokens, just bring in lots of extra context. So there are three technologies that we can use that really help narrow it down and keep it well behaved. And Anthropic seems to be doing a good job about trying to create some, standards of like, we're just going to say this is the standard and make everyone either feel guilty about not adopting it or trying to come up with something that's the same thing but different. And so I think you can use a lot of these in all the agents. We'll see. So the first thing is these model context protocol servers, skills, and agents. So I'll talk about each of these. So model context protocol, or MCP, and I think they're trying to rename it into something else that still rhymes with MCP. But it's a way to take your LLM and connect it to external tools like data sources or software libraries or things like that. And, so you could do things like have it, while it's reasoning about something, it can look at the structure of an HDF5 data set and decide see what properties are in there. It can go off and query the Copernicus climate data store. It can do PostgreSDB queries. And there's Anthropic also has a new standard called MCP bundles, which you can just double click on it, and it installs this server into your Claude desktop client. And this URL, mcpbundles.com, they've got a marketplace of like, whoa, a lot of MCP servers. Almost none of them are of any use at all to us, but let's maybe we'll change that. And so, okay, here's a good place where our view of using the LLM to write code differs from using the LLM to do its own reasoning. And so if you want the LLM to reason about climate data or weather observations, you would want it to actually get the data back. But for our purposes, what we want is Claude to know enough to generate Python code that'll go get the data when you're running the Python code. So this is one of those places where you have to stop, okay, wait, what am I doing? So Steve will show some examples of using an MCP server, and then some examples where no, the MCP server happens at the wrong time. We want this to be the Python code instead. But there's a lot of interesting stuff we can do, and I would love for ESIP to be thinking about, as a community, what are some MCP servers we want to provide to make this a lot easier for all of us. Okay. So then another thing is Claude skills, and I think it's Copilot, they call them hints, which is I think is a nice way of phrasing it. So this is us taking our knowledge, writing up basically some markdown files and maybe some templates that try to explain, no, this is how we do things. And so they really help to short circuit a lot of the LLM's reasoning, where it can just read this in, and it's like, no, I want you to always use this library. Use scikit-learn. I know you know about a bunch of libraries. Don't bring in weird libraries. Let's just always do scikit-learn. Or here's where you get daily weather observations. Use this library, and you can format URLs this way. And what's sort of nice about it is these documents wind up being pretty useful for onboarding new humans as well. Like a lot of this stuff, if you've been in the field for a long time, you have it in your head, or the documentation is spread all over the internet. And in order to make the LLM work for us, we've got to really boil it down. Like, this is what you need to know. And as it turns out, that's not bad for new people trying to learn how to become productive in our field. So there's some benefits there. So these are our Claude skills. Here's some of the benefits. So like I said, being able to really hone in on your experience and not pulling in like all the random stuff that the models were trained on. We're like, no, here's how to do it. The models have a degree of randomness in them. That's kind of the whole point of them, is it's all probability. And so every time you ask the LLM to do something, it might generate a whole other approach to doing it, which is kind of fun, but also kind of annoying that, something works, just stick with it. And so, and then being able to bring your domain expertise into it. So skills are a very important part in being able to kind of wrangle the models into doing what we actually want them to do. And then there's another concept in Claude, and I think most of the other coding agents have this, of agents. And so one of the scarce resource in using LLMs is context. And so as you start a discussion, it'll start adding more and more stuff into its context, things that it's thinking about and things that it'll use to try to reason on. And that's good. So you can, you give it a lot of information. But if you can find a way to say, you only need to know this for this long, and now this task doesn't need any of that context, you can wipe it clean and can go into another task without all this background information, and you'll save tokens. So it'll be more efficient, but also it really generates better stuff. Claude, like any of us, gets overwhelmed with just like too much information, and then it's like trying to draw too many conclusions. And so agents are sort of like subroutines where you can say, okay, here's all the stuff, and now I've got this namespaced information. The other thing is they can work in parallel, and you're giving instructions for a workflow, and so you can have an agent that just does coding, and then a second agent that just does quality assurance and looks at your code and says, or the generated code, and says, oh, these are bad ideas. You can have agents that try to pull out some scientific information from the code. So agents are a really important tool for really creating a workflow that the coding agent can do for you. And as it turns out, Claude is itself an agent, like all the Claude coding is just an agent. And so I asked AI to summarize skills versus agents, because when I've been working with this, I keep kind of shape-shifting, like, wait, is that a skill? No, it's an agent. So this is kind of nice. So are you looking at an agent or a skill? So building block capabilities, so they're like functions. Agents are more like orchestrators that plans work. Skills are put into just like a folder in your project with a markdown file and some resources and instructions. Agents are a little more complicated to configure. That tells it, how to make subroutines and how to all this stuff can work together. Skills typically are a little magical how they get invoked. If you just say the magic word in your prompt, it'll go like, oh, this reminds me of a skill that you told me about, and it'll bring that in. Sometimes it's a little mysterious, and sometimes I've had to ask Claude, like, did you use that skill I wrote for you? It's like, oh, no, I didn't. And then it's like, why didn't you? Well, you didn't say this. Like, okay, and then you can change that. Agents, you tend to more explicitly invoke. You say their name 3 times, and they show up for you. And there's other ways that you can kind of embed them into Claude. Skills are very much, you want to have a lot of skills. And so a project I'm working on, we've got a skill for telling it how to make a command line interface for my script. Just like, here's a really nice way to do this. Would you please consider this when you're making my script? So keep them pretty narrow, and you'll get better results out of it. Agents are much broader, like planning and delegating and all these kinds of things. And an agent, you can explicitly say, use this skill, which kind of removes some of that magic. And then skills are very reusable. And so again, I would love if we start building a collaboration of ESIP skills, because I think there's so much knowledge in this group, and if people can use them in coding, then that would be terrific. And the agents are going to be much more for a particular use case. So like if we're talking about an agent that helps you build a machine learning training script, that would be a really good agent that has kind of its own workflow about, like, it would have to know about taking the data set and splitting it into training and validation, those kinds of things. So when I first started learning about skills, I was like, oh, but wait, how do you distribute them? Because that's really the key, is being able to have the community create them and create and curate them. And then, iDream and Anthropic fulfills them. They finally came up with this notion of a plugin, which is nothing but a zip file that has skills, agents, and custom commands in a particular directory structure. And then they have a concept of a marketplace of plugins, which is just a public GitHub repo that has a JSON metadata file in it. But then it's very simple. From there, inside the Claude CLI, you can say, I want to install a plugin. It says, oh, where's the marketplace? You put the GitHub repo in there. It lists all the plugins. You install it. And now it's available for your project. And so here's my next dream, is that we on the ESIP website, we create a marketplace of plugins, and people, as the good thing is you bring them in, you use them. Claude makes some dumb mistake, and you say, oh, next time, please, do it this way. And so they'll keep getting better and better and bring in a lot of the knowledge of our community. So, summary, don't use LLMs to do math, but do use them to write Python code or R code, that the scripts query data set, do the math, and plot the results. Claude Code is a popular one. There are other ones, and I would love for that moment when we can start looking more at open source. Every now and then I have colleagues who share like these knowing blog posts about, all those productivity games people talk about with LLMs, they're not true. Don't believe those blog posts. It is, I just am been so amazed at what I'm able to do with them. And one of my favorite things is I don't do JavaScript, and now I'm a JavaScript developer without ever having to look at it because I don't really understand it, and it's pretty amazing. We need to augment these with MCP servers, skills, and agents to make them useful for our applications. And then, hopefully we'll someday transition to open weight models and open source agents. So I'm going to hand it over to Steve, but we could also have a few moments of Q&A at this point.
Yeah, people should be able to unmute themselves, or you can type in the chat any questions. I'm going to take the spotlight from you, Ben.
Oh, thank you. Oh.
I have a quick question if no one else does. Awesome talk. Thank you, Ben. That was really interesting. I'm curious, like you're describing like creating a marketplace within like ESIP, and I love that idea. And you kind of mentioned like having something where like you're using it and you're realizing, oh, like it did it this way, and it'd be really nice if I could tell it to next time kind of change the way it does it. Are you envisioning like a marketplace that just anyone can be updating these things? Like I am just kind of wondering, like in terms of who is able to access it and actually edit it.
I think just the plain old open source workflow.
Okay. Mm-hmm.
So probably somebody who cares a lot about this would be the maintainer, and anyone can make a pull request.
Okay. Cool. Yeah, this was an awesome presentation. I'm going to be thinking about this.
Thank you. That's the idea.
Could I ask a question of you, Ben?
Sure.
I've been trying to experiment with MCPs to kind of capture knowledge as I'm doing work, and document it. And we've kind of come up with, Claude and I have come up with a tree of markdown documents with kind of a level of detail there. As you descend the tree, you get more specific information. But several times I've just been caught in almost a catch-22 of where the chat length and the body of knowledge has outgrown my ability to capture that information, especially if I don't start early capturing it. Is there any strategies? I know I can get online and read the literature, but nothing obvious other than this. Other people have seemed to have adopted this approach.
So is this like what is it in Harry Potter, where you take your thoughts out of your head and stick them in a jar, where you're trying to like manage your context, and here's a bunch of really great ideas. Don't think about them all at once, but be able to, like, a database of concepts that Claude is coming up with? Or is this your thinking?
A lot of my thinking, and I know this is tangential to this group specific topic, but mainly, like, recently I was handling an intrusion detection on a legacy server of ours that was hosting some really important stuff. And I was going in and doing forensics and wanting to capture a lot of information and so that I could document it for very important reasons. And I needed to be able to present that back. And I was hoping as I was doing this very detailed work and going and exploring lots of stuff, that dense information was being captured and that I could start to generate documentation from it as I came back out of the rabbit hole.
Yeah. So you can come up with like a directory structure and ask Claude to summarize like what it has in its head and then move on to the next thing. Skills are really good way of kind of managing the context, because Claude can do searches and decide when to bring something into its context or not. And then there's this whole other field that I've just, I think we're all like drinking from the fire hose at this point, but of knowledge capture. There's a technology called Bead that I just read about that is like a database of concepts to try to take stuff out of Claude's context and put it into a database that then Claude can use as an MCP server and reconsume. Yeah, there's a lot there.
Okay,
we should
be. Yeah. Thank you.
Yeah.
There's an interesting question from Carl in the chat. Ben, have you experimented with sharing existing code for review and modification? I've got a spaghetti code, the base, that I want to update and modify.
Yeah, it's really good at that, at taking something that you don't understand and explaining it to you, and you can ask it to write like a markdown document explaining the architecture of the thing and do all that sort of stuff. One important thing when using Claude Code to modifying your code base is use git, make a branch, and every time it does something useful, commit it, because it really loves to take something that's working and then do something horrible to it. And so you're going to really appreciate being able to roll back to something that was working before. Yeah. Oh, God. There's speaking of translating things, there's this person who has really upset the open source community. I think he's a Dask contributor who made a machine-written pull request that is too large for any human to ever review it. And so there's been lots of discussion about that. And one of the things he did is, like, in a couple of days, translated all of NumPy into Rust, calling it Rumpy, I think it's called. And so they're very good at doing that kind of thing.
I think you touched maybe maybe you didn't touch on it. Someone asked, have you looked at DeepSeek? Was that already
Oh,
touched on?
I have not. So this is an open weight model, meaning that it's the open version of open. It's what we call open source for models. DeepSeek looks pretty good. I don't know how to pronounce it either. QN is now kind of the most popular one. It'll be interesting for all of us, especially people that might be paid by the federal government, about what using a Chinese model what eyebrows that might raise. So yeah, there's some interesting things there.
And then one more question just came in, and then maybe we could move to Steve.
Yes. How you decide to go forth with Anthropic versus the other products? It's peer pressure. I have colleagues who spend a lot of time, much more time than even I do, on this, and they say that at the moment, Claude Code is the best one. I'm sure that's going to change several times. The thing I really appreciate is they seem to have really thought about the ecosystem. And like I say, they're trying to push these standards through for how to do things like skills and agents. But yeah, it's frustrating that it changes so quickly. Just when I think, okay, I've got a pretty good mental model of this, then there's like, oh, here's this new technology that changes everything. Oh, great. Fun. Thank you, everyone. I've been looking forward to this.
Go ahead and answer.
Yeah.
We've got, you're running the session. I just want to make sure we don't run out of time for the second part.
Yes. Steve, let me know how nervous you're getting.
I'm all good.
Okay. I have a terrific example in high energy physics, if that's of any use to anybody. I think, Steve, you probably have a nascent set of skills for earth science. But yeah, I can definitely share. I'll put into the notes. All this was inspired by a collaboration I'm doing with the University of Washington, actually. A physics professor there who has really pushed a lot of this forward. So I can at least share that, but hopefully we'll have a good example in earth science. Okay, I will stop sharing. Thank you, everyone.
Hey, Steve, I will spotlight you, and I believe you're sharing, so.
Okay, very good. Thank you so much. First of all, I want to call out Ben for kind of giving me a kick in the pants on this talk, because it really has formulated a lot of interest in our department, given the advances in AI and weather forecasting, and then now how we can use these kind of technologies, including LLMs, to move our research forward and understanding the climate as well. But also, my other hat here is obviously I'm an instructor, and within our department, we have come up with what is now amazingly the largest graduate program in weather and climate here at U of I. We have over 70 students who are attracted to this online program that culminates in a master's degree in weather and climate risk and data analytics. And giving a little bit of a commercial here, but obviously those of us that are teaching courses in this program are very impacted by the rise of AI and coding, because even in my course this past semester, I noticed that I started the semester with your typical code that looks very rough, doesn't have a lot of comments, it's formatted poorly, and it sort of works. But by the end, surprisingly, somehow all the code was almost perfect. The formatting was perfect. The comments were extensive, and it kind of led me to scratch my head a little bit that maybe the students aren't coming up with a lot of this. So given this fact, obviously as educators, we need to be able to harness this power for the good of the students. And obviously, we need to wrap our curricula around how to teach data science and machine learning in this modern era. This is all brand new to us. Maybe the students are further ahead than we are. That may be the case, but obviously this is here to stay. And my personal opinion is that we can't put up sandbags around us and wait for the water to flood over the top on AI. We've got to really start to get on top of this. so that we can benefit our students, because my students that are out in the workforce are already using these same tools as well. So, given the context that Ben put forth, what do we really want people to learn, right? We historically have created pedagogy around this topic that talks about how to implement ML models in tools. But is that really what we need to be doing anymore? Given the fact that students do spend a lot of time, and obviously professionals spend a lot of time battling their syntax errors and coding problems and everything else, is this going to be going away? And to what extent? Uh, if that is the case, does that allow us to spend more intellectual time actually thinking about the data itself, rather than worrying about how to code around the data? Uh, Also, does it allow more time for us to get into some of the math of the model, rather than teaching people how to use PyTorch and all of its intricacies in working with certain GPU models and everything else? Does this free us up to think more about science? Uh, what do the hyperparameters actually do in a machine learning context? A lot of us, I mean, is that a black box for most of us? Probably. Do we just put in a grid search and say, yeah, find us the best answer? Well, can AI help us understand that a little bit better? And in terms of uncertainty, how do we evaluate models? Well, there's a lot of literature coming out, a lot of preprints coming out on these techniques. It's a lot to digest, and it seems like the pace is getting faster and faster. Probably AI is helping out the research process so that we're getting more and more stuff out there, and we may need help to be able to sort of distill a lot of this. So, given all these challenges, where do we start? Well, I wanted to get into a few case studies here, things that I've sort of played around with in the last few months that have been maybe revealing to me, but also kind of shows the power of what we have perhaps to offer students. And of course, one way that we teach is to look at case studies in atmospheric sciences. And a lot of times in our classes, we might go back to an old paper and say, hey, let's look at this classic paper and see how they did it. So how could AI assist us in this technique? Well, of course, when we're talking about FAIR principles, reproducibility is an important thing. Reproducibility is hard. Actually, AI can help us address reproducibility. And I'm going to take you through an example here. So what I did is I just said, well, I'll take a class from my tropical meteorology or a paper from my tropical meteorology class here. Classical paper on understanding the effects of El Nino southern oscillation on mid-latitude weather. This was a paper by Horrell and Wallace from the University of Washington in 1980. And the paper basically was the first to show that this tropical pattern of SSTs starts to impact our winter weather in the mid-latitudes. A lot of the data sets are long from being open. They're gone, probably, in a lot of ways. A lot of the analysis was actually done by hand, and the figures were drawn by hand. So, trying to reproduce this study would be somewhat difficult, but we do have things like reanalysis data and ERA 5 easily available. So how might we go about reproducing this study using AI? Of course, I could do it myself, but what about AI? So I give this to a bunch of students and I say, well, look at this paper, but now they can actually code up the paper in almost no time. So the key methodologies in this paper, it actually does use some machine learning. It uses empirical orthogonal functions to identify SST patterns, uses correlation analysis, some more traditional climate dynamics, composites, and these are common analytic workflows in many climate dynamics papers, and so students should understand at least that these approaches exist and hopefully understand some of the underlying mathematics of eigenvectors and eigenfunctions and things like that. But could Claude figure this out? Well, my first attempt was just to use a chat interface. So I used Claude and I attached the paper and I said, um, reproduce the paper, create a Jupyter notebook that will have all the figures in the paper. I wanted to sort of add a skill in here. So I said, use an MCP server that's already out there. And this GitHub repository contains an MCP server, but that MCP server doesn't actually download data above the surface. So I asked it to modify it so that it could do that. So in meteorology, we have different pressure levels, which are vertical cuts in the atmosphere. And this paper uses data from those levels. So I told it to modify the MCP server. You'll kind of be surprised about what it did about that. And I said, try to modulate, or sorry, try to match the paper as much as possible, and develop some skills so that it can do this again in the future. And I uploaded the manuscript, and I said, look at it. This is a completely flat PDF, okay, from 1981. So there's nothing in there but images. Well, a few minutes later, it said it was done. It created its own MCP server to be able to customize ERA 5 data access, which I can share with you if you're interested. We created notebooks reproducing all 10 figures. It had some skills that had some climate analysis and visualization best practices. Those included computing the empirical orthogonal functions and the composites. And it said, yep, all done. Of course, then the question is it right? Does it work? Well, of course, no. First thing I noticed that it tried to download every file sequentially from the data server. That takes a long time at the Copernicus server. There's a queue that takes time. So I said, well, go ahead and don't do that. Download the whole thing at once. And it was able to do that. Modified the MCP server so that it had that capability, and then it knew how to call that. Now, does the code actually work? Well, since this was a chat interface, it didn't have access to my local files. So I was, started getting errors like, oh, I can't find this file. Couldn't import the MCP server. Was able to fix all of those problems basically just by sort of pasting error messages across into the chat interface. But eventually this is going to drive you nuts because depending on how much code you have and how challenging it is, the context within Claude is not going to know what's going on in your local computer. So, for example, you might notice an error, obviously, and fix it yourself, but then you might have to upload that again, and so it knows what you did. Even if that's not the case, and you're just trying to work through a lot of these errors, this will take a lot of time, a lot of copying and pasting. It's kind of like, sometimes you see students with a chat GPT window on one side and like a homework on the other side, and they're just kind of pasting back and forth. Well, it turns out there's a better way to do this. And in some case, I find myself kind of going numb, and am I really thinking about what I'm doing here? Because I'm just copying and pasting and keeping track of errors. Have I really done anything better than doing it myself? Well, so we switched over then at that point, and I re-asked the question within Claude Code as a coding agent. So I basically said, okay, here's the same question. I gave it a blank slate. Here's my paper. Solve the problem. Well, I only have the Claude Pro subscription, and it turns out that it ran out of tokens by doing that. It was too big of a problem. I've heard that some people will say, well, then try to break it down into smaller problems so that you can get through it. But then I got the idea, why don't I just take the existing code base that I already had in the chat session, make that a GitHub repository, and ask it to work on that, and take my existing code and make it work. And that took almost no time at all. Once it had that context, it worked really well. Still some errors, but within the agentic window here of Claude, it's able to look at my code. For example, the first issue I got was, once I got the code actually working, I had a kernel panic because it was trying to do a huge matrix inversion, and I ran out of memory. Well, I just so happen to know that you don't have to do the raw matrix inversion in NumPy. You can actually use a package called EOFs, which is written on the back end in Fortran, and it's much faster, much more optimized. And I said, use that, and it worked. So that was not really an issue, but it used my expertise, and it would have been good to have a skill that would have said, hey, use EOF package because I know that works. Other common errors that came from sort of my experience. So when I ran it, it took a long time, and I'm like, this is not a big data set. What's going on? And so I literally just wrote, this is taking forever. What's going on? And it said, oh, well, I can optimize my X-array functions to be vectorized. And that sped things up by a factor of about 100. There's simple errors like syntax errors, dimension errors, improper uses of functions, but the agent was able to figure those dimensions out and fix them all. And then there were some errors where actually the paper I found was not written very well. It wasn't clear about what it was doing. And so I can't really blame Claude about making errors in the results. I was able to fix those by looking at the output. But in all cases, the fixes were applied and the code appeared to be running, but was it correct? Okay, so let's take a look at some of these results. So here on the left, we'll just go through one example here. This is kind of the winning figure of the paper. It basically shows the correlation between 700 millibar geopotential height. So for non-meteorologists, this is basically where you just have low-level highs and lows in the atmosphere. And it related them to the sea surface temperature index, a measure of El Nino up here on the left. And what you see is actually the patterns here match up exactly, or almost exactly. You have a high here, low off the East Coast, low off the East Coast, low off the West Coast, okay? Big low off the East Coast of Asia. So I would say yes. Similarly for the upper level pattern. So at the jet stream level, again, you see very good similarity, okay? You kind of see this, what we would call a Rossby wave pattern that's emanating out of the Pacific, and that impacts the weather in the mid-latitudes of the United States, okay? Now, these other two, this thing called fanning rainfall, it doesn't match up. And the Southern Oscillation Index also doesn't match up. So I went back to Claude and I said, well, these don't seem to be working. Do you have any ideas what's going on here? Well, to be surprising, what it said was, you're using reanalysis data, which is a model. The original paper used a rain gauge. So why don't we look at the rain gauge data and compare it to the model? And it performed this analysis for me. So it couldn't find the rain gauge data that the paper used, but I was able to find it. And it did this analysis to compare. It did a scatter plot, time series, and difference histogram, annual cycle. And what you see is that there's a difference between the data that was used in the paper, the red or the black line, and the ERA 5 data. So maybe it's not surprising that the patterns are different, is because the rainfall data was different. And then with the SOI, when SOI was computed from ERA 5 versus the SST data that was used in the paper, which is not available anymore in digital format, I found that there's actually quite a weak correlation between them. So were there errors in the original SST data? Who knows? I mean, it was basically ship reports versus a modern data assimilation system. You do see some correspondence here, but it's not quite the same. So it's not surprising that the patterns were different. Additionally, one thing I didn't ask for was that, for example, these dotted lines on here are the areas that meet statistically significant differences. Okay, so what's kind of interesting, the original paper makes conclusions without doing statistically significant or statistical tests, right? You can actually see that a lot of these smaller regions are not that significant. Okay, so maybe some of the original conclusions may not have been robust. Not sure. So that's something that maybe we've learned in 45 years since this paper is studied, that we need to do statistical significance tests on our results. But it was interesting that the AI agent added that based on its thoughts. So conclusions from this exercise, the chat agent actually was able to do a reasonable job here. There were bugs the chat agent provided answers to. Agentic coding certainly accelerated this process. And when I had follow-up questions, it went way beyond what I actually asked for and provided a lot of context. So what about moving to a machine learning question? Of course, AI, we're assuming AI is here to stay. But of course, going forward, how do we construct pedagogy, assessments, and goals in an LLM-enabled data science environment? And are there advantages to this new paradigm, and how do we adapt as educators? So just to kind of summarize here, the idea here, and this is obviously an AI-generated slide, thanks to Notebook LM, based on all the output that I had. I just plugged it in there. We can talk about that in another ESIP talk, but basically the idea here is that can we, if AI is going to be a black box anyway, can AI help us interpret it? And I think the answer may be yes. It can help us as students use a natural language prompt to get over some of the syntax issues that we might be challenged with, and maybe allow us to focus more on the data and the results, and even enhance our interpretation of the results. So just to kind of wrap up here, here is access to our MCP server if you're interested in using it or enhancing it in your own research. I'll just show you some examples here. I wasn't going to do this originally, but I have the ability to plug this directly into my Claude session and ask questions. So for example, I did this right before the talk. Can you make a map of temperature departures at 200 hectopascals for March 2024? Use this 30-year period for the long-term mean. Only calculate and display the values over North America. And lo and behold, I lost my window here. Well, I guess I closed it. Let's see, what did I do with it? Sorry. Let me find my folder here. There we go. It was able to, within 30 seconds, create this plot for me. So these are the departures from the long-term mean. I then said, can you make this for precipitation and show percentage and absolute anomalies? And 30 seconds later, I had this figure, right? So these kind of things, we don't need to mess around with code for much longer to make simple things like this. But then obviously going forward in a machine learning context, when we're starting to get into the complexities of deep learning and machine learning, convolutional neural networks, other things, can we push it so that the student can have better understanding of actually what's going on under the hood, right? So we did a quick test. So we gave it a problem. We said, and this is kind of a naive problem, but what we said was, okay, let's look at monthly precipitation anomalies in era 5. How how does that relate to 700 millibar temperature, wind components, specific humidity, to explain those anomalies relative to the precipitation anomalies? Nothing groundbreaking here, but which it might be more important. So in the old way, you would, the way I would teach my students in my class as of 6 months ago would be, I have to train the student how to download the data, get Python installed, write data cleaning scripts, modify machine learning code, and get it working. But we were able to do this on the right with chat prompts. Okay, using our MCP server to get the data, and then have it develop the machine learning code. We also asked it to look at uncertainty and intermodel variability, hyperparameter searches, and things like that. Now, of course, the students need to make some decisions because, for example, they need to know about how to train and test models. They need to know how to understand overfitting and other biases about how model construction can influence things. So the students, to get for example, if this was an assessment, they would have to be able to come up with these prompts correctly, so that they have to demonstrate that they understand how machine learning works. Right? They would have to select a model. They would have to understand what their target is, what their features are, and then understand, the basics of training and testing, validation, and hyperparameters. Right? That's not going away. You can get recommendations from AI, but certainly they need to know these things if they're going to do this well. And so when we prompted it to say, "Hey, explain your results," it was able to come up with doing what's called a SHAP analysis, which is a way in random forest models to look at the underlying statistical relationships between the features and the output. And it also allows you to isolate those contributions by feature here. And so what it was able to do is come up with an analysis that showed that the biggest impact on the model output was the moisture at that level. And it gave a lot of statistics about the skill of the model through an AUC curve and all these other things. So it gave a lot of insight sort of beyond what we prompted it to do. It also, when we asked it to demonstrate its robustness, it was able to come up with a sort of an ensemble validation approach with different random seeds to ensure that it was robust. And it also sort of looked at some of the hyperparameters. So it looked at, for example, the tree depth and the min samples parameter, and it was able to produce visualizations of how these hyperparameters were resulting in the performance of this particular model. So it was kind of interesting. It also gave us this feedback. It's like, well, if you really want to learn about precipitation, you might want to use monthly data. You might want to look at daily data, which is a fair point. Because obviously precipitation tends to have is very episodic. So you might not expect short-term precipitation variability to be related to long-term means, which was a fair point. So obviously the elephant in the room here is how much of what is coming out of these outputs is usable, and the hallucination problems of LLMs is obviously an issue. We talked a little bit earlier about code hallucination where it made syntax errors. And obviously those are flagged, obviously, because it doesn't work for the most part. But then what about scientific hallucinations? And am I still here? Yeah, I'll drop some other people off here. But anyway, So, for example, if you see output like this, where you're able to predict things perfectly, that's probably not correct. But these things could be subtle and could be dangerous. And so, solution here is you probably need to set up a mitigation strategy to make sure that you're able to identify hallucinations and impacts in your predictions. So, I don't know if our other author was able to join, but I'll talk briefly about the role of retrieval augmented generation. So I did not provide my questions, for example, in my case studies with anything but the current paper that was under consideration, right? So from that point, it had to use a lot of tokens for perhaps to find methodology and code where it went out. But of course, tokens are expensive. So RAGs, by augmenting our searches with previous information, for example, it could be papers, could be previous code that's out there, will help the agent and the chat client sort of narrow our search, and even add, in an ideal world, proper attribution of our findings related to either techniques or conclusions that we get out of the model. So this will help us hopefully narrow down our usage of tokens, base our findings on the literature rather than trying to, trust the LLM to come up with an answer, and then also increase study or the proper attribution of prior work. So what about grading? So this was really interesting to think about, and my student and I we talked a little bit about this. Like, how do you grade somebody using AI? You kind of think about AI as sort of cheating in some ways, but if we bring it out into the open, really, if you're using this as both a way of learning and a way, kind of testing the student and how they use AI, we have to sort of bring the chat window into the assignment, right? So a student that just goes out and uses AI and just dumps their answer into their results would not earn a good grade, right? Really, it's about the student having skeptical inquiry, checking the AI's results, giving it proper context, developing skills using MCP servers that you trust, so that you can use these tools. And then somebody who's excellent will be able to find all the errors and solve them so that they actually are able to hopefully produce a correct analysis. So here it's sort of, as a professor, thinking very differently about these tools in an era where the entire world's knowledge are now at the student's fingertips rather than just a textbook, and using those tools to be able to advance their own understanding and scientific understanding. So really, it's kind of summarizing here, rather than worrying in sort of a data science education about coding syntax and library mastery so much, it's more about experimental design, result interpretation, and verifying the output. I believe once you learn how to use these tools, I'm in agreement with Ben that this certainly accelerates the process tremendously. If you are able to narrow the search down using skills, MCP servers, and giving it the right sorts of prompts, you can definitely accelerate these things. And then the pitfalls here, of course, in the traditional way, is sort of debugging, Stack Overflow, and fixing things. The worry in AI, of course, is there hallucination or misinterpretation? But maybe this can be honed in through the development of community-based skills and MCPs. And one example of RAG in education that we have is at Illinois. We have deployed a RAG server called chat.illinois.edu. You can log in and use a variety of different models. For right now, these are set up so that you can use the open source models, or you can also plug in any subscriptions that you have. But it allows you in a safe, secure environment to upload materials like your textbook, your code base, or other things, and allows students to find information without bugging the instructor at some level. That, of course, can reduce a little bit of interaction between students and professors, perhaps, but also for people who are maybe not inclined to ask questions of the instructor because they're intimidated or other reasons, as distance, etc. They can get answers whenever they want. There's still legal issues here, of course. If you're taking copyrighted material, putting it on there, what does that mean? And so, but maybe they can start to work on things like, creating real life examples of theoretical material. Like, let's say they have an equation that they're trying to understand how it works. They can maybe ask the prompt to give it a real life example and describe the mathematics, or even create visualizations that they could better understand. So I think that's a pretty exciting opportunity, especially for students who are willing to ask those additional questions. Of course, Ben touched on this broader discussion of the role of AI in science. This is a change, right? There's going to be a lot of potential benefits and drawbacks that I think we need to have a lot of discussions over. This is obviously just happening as we're watching it. And hopefully we can have a little discussion here today about this. Ben, I don't know if you want to unmute here and say thanks.
Sure.
I think this is the end of our formal presentation here.
Yeah. So big thanks to my collaborator in high energy physics, Gordon Watts from University of Washington, he started doing this work on in physics analysis. It's like, whoa, there's a lot here. And so I've been dragged along on his coattails. And then I'm very fortunate to be funded in part by a particle physics grant that's allowed me to do some of this. And also the state of Illinois is funding some of my work with Steve and his department as part of this Illinois Computes project. So that's us. That was exciting. That was exciting, Steve. I purposely didn't look at your slides. I wanted to be surprised, and that was great.
Oh, thanks, Ben.
Well, thank you. Thank you both. If people want to unmute and ask questions or post in chat, we do have about 20 minutes left. I do also, really quickly before we get to questions, just if you haven't already gone and either added a topic for the upcoming Birds of a Feather coffee break, or just looked at the topics and upvoted what you want to talk about, I'm posting that in chat. We're going to close that at 3 p.m. Eastern time. So if that was something you wanted to do, last call. But yeah, let's, if anyone wants to ask questions or look at, there's a resource in the notes document on Kiko Chat. I'm going to give the floor back to Ben and Steve.
Other Steve.
I can't resist. This is just kind of a test probe, okay? But there's been speculation for decades, I think, about an association between the solar cycle, the 11-year solar cycle, and weather patterns. So I think what I'm hearing is that it would be possible to explore that line of inquiry somewhat readily if you had the skill set that you've developed, and kind of see, well, what comes out of taking a look at that. Am I on the right track there?
Absolutely. There's nothing, I mean, that sort of question is readily accessible. Of course, understanding and asking the right questions to get uncertainty information out of that question, I think takes a little expertise. And I think there is a little bit of a danger here of somebody malevolently using something like this to produce an analysis that might be not robust, I would say.
Yeah, I hear that. Very very interesting though. The potential to maybe plow some ground. That looking at the unexpected is intriguing to me. Thanks.
Yeah, great question.
Madeline?
Yeah. Great presentation, both of you, Steve and Ben. I guess this isn't like a fully formulated question, but I'm thinking of like your case study where you were reproducing the 81 paper. And I guess like the results from that seem really interesting, and the finding that like potentially with this kind of new data source that's more accurate, like we see a different picture. Like I could picture that being a like article that people actually find useful to read. And I guess I'm just curious, like, what your take on this is when, like, you can basically redo some seminal paper in an afternoon and, like, have some potentially really interesting findings from, like, looking at what you're seeing. And obviously, you'd want to do due diligence of just kind of like making sure the code is actually doing what you think it's doing. But, like, I guess it's just like almost mind blowing to me that we're existing in this time where like you could do this really cool analysis in like a day and like what? Like, I don't know. I guess, yeah, I'm just curious on like anyone's thoughts on just like what that looks like in terms of like how we publish things and like what's worth publishing. Cause like I genuinely would like to read that paper now. And so I'm just like, do you then just publish things that you've worked on for 2 days or what's your, yeah, what are your thoughts?
I guess I'll take a first hack at that, but yeah, no, it really, I mean, it's unbelievable. Of course, one of the first things I did was I tried to redo my PhD, and I did it in like 3 hours. Um, so, I mean, it's a little bit, one that was one chapter of my PhD. I should be more specific, but yes, I mean, partially that was due to open data sets and not having to spin magnetic tapes for days and days and things like that. But I think the other part of it is that it sort of, I mean, the power of this is immense, and imagine reviewing a paper and being able to reproduce it while you're reviewing it. If you're skeptical, I mean, I think we're gonna. There's power to produce a lot more science, but then also make sure that what we're doing is correct. And I think it just potentially opens up a lot of better ways to address FAIR principles. Um, and yes, we are going to find that old things sometimes are not right, and that's going to accelerate. But that's a good thing. We don't want to be making decisions about risk and climate on bad information. So
Absolutely. Yeah.
Yeah.
Thanks for that response. Yeah, Ben, did you have thoughts?
Yeah, I mean, I'm not from this industry, so I have not much to add. But it is interesting. Like, do you cite Claude in your paper, and do we know how to do that? And like I've found, I've gotten over this now, where I'm working on a project and I use an LLM to do my coding, and I'm just embarrassed that it's such a ridiculously complete solution, and I didn't even work very hard. And so for a while, I was like, maybe I won't check in all this documentation because it's just embarrassing. But I think we have to get past that. So I have it's interesting. I made this whole point about MCP servers and not being useful for LLMs. And then you went on and used an MCP server in the LLM. And I think Douglas shared about Anthropic's Claude Cowork, which is a desktop application, and it behind the covers will write and execute the Python code and then just give you the results. And so I think that's what's happening, Steve, that the LLM is actually, in this case, not showing you the Python code that it wrote, is running it and then giving you the plots. So that's interesting. I hadn't actually thought about that, but it's like, is I mean, probably for scientific research, you'd want to see the code. But in terms of just like poking the data, it's pretty nice that you don't even have to even think about code.
Yeah, I mean, for users, like for example, if I were trying to decide whether to apply pesticide on my farm this week, I could just say, I live here, tell me the forecast, and make a custom prompt that maybe the National Weather Service wouldn't give me. But I need to know between 4 and 6 p.m. if the wind's going to be above 20 miles an hour. I've got that information. I mean,
Hey, Douglas.
Thanks, Steve and Ben. Steve, I think at the end of the presentation, you kind of touched on the validation of the outcomes itself. And I think more that goes to some earlier questions, like how, because when you're trying to reproduce a results from existing paper, you can kind of validate against those like published outcomes. But when you're trying to explore new things, trying to get an output, and so how are you going to try to verify if that's something that's actually real, but not the things that they just make up a map and looks decent and maybe sensible with the geographic features. And that is probably one issue need to be addressed, especially in teaching settings, right? That like how are you gonna look at the outcomes from itself? And I think there's also upcoming like challenged with I think now in a lot of computer science conference, they're already seeing the rapid increase of submission itself, what they call basically DDoS for the of the LLM to the submission systems. And now what they're trying to do is kind of trying to address those inflation of the submissions in those conferences that by requiring that all the submitters will be signed up as a reviewer as well. So if you submit, you have to review as well. So it's an interesting ecosystem right now we're in, and what it may look like. I don't think it has like reached to the geoscience peer review publication systems yet, but I can see that becomes quite like relevant soon-ish.
yeah, I guess I'll just say a couple of things. Yeah, of course, the students need to understand and hopefully, be able to at least look at the code and say, yes, this is doing what we think it is. And I would hope that in the near term future, we develop better techniques to do that validation. And I think there are approaches that we could take. Having it to, for example, just try asking a different model to do the same thing and see if you get the same answer. That would be one way to do it naively, but yeah, having a way to look at the code at least and make sure that it's doing something reasonable. But yeah, I mean, in terms of submissions, I do think it is already here in geosciences, maybe not as pervasively, but I have noticed that, and maybe this is a good thing. I mean, one barrier, of course, is writing in our field, especially for people with different backgrounds. And maybe this helps level the playing field and making it easier for people to produce high quality content. I mean, I think that may improve the quality of our publications at some level. But obviously, you have to attribute the sources and make sure that we're following all the good practices of making sure that things are reviewed and validated properly. But yeah, it's a interesting time.
Yeah, it's been having discussions with some developers, and there's a couple of tools that will lash together multiple Claude Code sessions in like a chariot style and like draining your account very quickly. But the kind of a growing model is don't even understand the code, that you find ways to validate, is this actually what you want? And I've likened it to that is to programming as machine learning is to like the physics processes. It's like if the loss function's low enough, how we got here, I don't even care. but I can, maybe I wouldn't want to do that for the control system for my airplane. But for a lot of stuff, it may be that we no longer even care about the software, just the results. One other thing that's been, so interesting for me, and I'm sure it'll be interesting for a lot of us in this community, is data centers. I have a friend who's like planning a protest in Portland about data centers, and she wanted my input. It's like, oh, I am so conflicted on this. So we'll see where that goes.
Yeah, I would post the ICAR conference. They have a policies now on the LLM generated papers and reviews specifically for started from this year.
Any other questions or comments for the chat? Got about 7 minutes left in the session. Again, if anyone has any takeaways that they want to impart, they can put it in this document in the Kiko chat. And I believe we make these available afterwards. So Steve and Ben, if there's any resources you want to share with participants afterwards, you can put them in here as well. But I'll keep this open another couple minutes if anyone wants to say anything else. Last plug for voting for those coffee break topics. I think we have 3 so far. We were hoping for 5, but that just means more people in the breakout rooms. So no problem.
Thank you, everyone. This has been such a dream session, and great. I really appreciate all the feedback and chance to talk about this.
Well, thank you for talking. As you said, it's a different experience than the in-person, but still able to impart a lot of information. So thank you.
Maybe you can do an updated session in Austin.
There we go.
And Maddie, thanks for joining and supporting as well. Your first session.
Yeah. This was great. Oh my gosh. Thank you guys so much. This was such a fun session. It's funny because I felt like I was doing an okay job staying up to date on like how people are using AI for coding, because I'll use like ChatGPT, but mostly just like in that like chat kind of format. I need to level up my game, it sounds like.
Yeah.
So this is awesome. Yeah.
I've been battling like this feeling of overwhelm for the past year. Like, oh
yeah.
And
yep. And I don't know. I keep going back to kind of the age old question of just like, what is my role in this process and like in developing science, and what do I want to allow AI to kind of take over in my life versus what do I want to retain heavily
right.
influence over. Yeah, I feel like I change my mind about that every day.
And it's an interesting question of like how much do Steve and I have learned from doing this the hard way that allows us to really be more effective using this technology. And if you grow up using this technology, will you have those skills?
Yeah.
I don't know.
I think about this all the time. I feel so lucky that like I learned at least basics of coding before this was an option. Mm-hmm. So it like forced me to just, get used to some of the basics, but I don't know.
Because now why would you would be so unmotivated to learn?
I mean, it takes, and it takes time. And it's like, I mean, Steve's case study was a perfect example of just like, you can do so much in like one day. So yeah. Wild time that we are living in.
For so many reasons.
So many reasons. Yep.
Yeah, I have a friend who's a collaborator in Argentina, and his daughter went on ChatGPT and created an app that produces real-time flood warnings for her county.
Uh-huh.
And she distributed that through the government. And so now people receive real-time flood forecasting. And she's now 16, and I think she's got offers from Stanford and MIT, and you know,
That
it's
is
amazing.
wild.
Yeah.
That is wild. Oh my gosh. Wow.
And then Rajendra, there's a question in chat.
Oh yeah.
I hope so. So whether students would benefit from basic boot camp coding, I would hope so. I mean, full disclosure, I think computer science degrees, I don't understand what they're for, but boot camps seem like such a valuable thing. But yeah, is coding going to be like arithmetic in the age of calculators? Like, why would you do arithmetic?
Yeah. No, thank you so much. Again, I'm kind of the generation, right, that is seeing the huge difference. And even in these past, even though I've been outside of the earth science community for a bit, the same things, of course, of like 10 years ago, people are like, oh, people don't know client, command line anymore.
Mm-hmm.
How's that going to impact us? So yeah, similar basic questions that everything's changing now. And what is important and what is not. That's what we have to think about as teachers and as students, of course. So thank you again for a great talk.
Thanks.